the length of the rod in unstable position? Unstable equilibrium position means maximum potential energy. So with respect to vertical, it is when exactly above the top, then it is in the unstable position. Now, after that it swings and come back to a position here. This entire rod is coming to this position. Okay. There is a swing. Let us consider with respect to this vertical, this angle is theta, as mentioned in the diagram. This is point O, about which it is clear. So we have two positions. One is this one, another is this one. Since it is moving under conservative forces, only under the action of gravity, so we can apply conservation of mechanical energy to solve the problem. Now, at this position, what is the total mechanical energy? Rest means kinetic energy is 0. We have to calculate the potential energy only. Now, for the calculation of the potential energy, we consider a particular reference line, and with respect to that, we will calculate the potential energy. So, let us consider this line with respect to which we will calculate the potential energy, or another line we can choose, which is this center of mass. I will consider the center of mass because rod is an extended mass, so we will consider its center of mass. So its potential energy at this point will be with respect to this line. The center of mass passes through this point, and we consider this horizontal line as the reference line. This is the reference line we choose. With respect to that, first we calculate the potential energy of this mass. This mass can be concentrated at this point M. Entire mass of the rod can be concentrated at its center of mass. Then what is the length of this mass above this reference line? It is L by 2, L by 2. That is L. So it will be mg L. This entire length of the rod is given L. Okay. So I consider center of mass on this side, and this side, when the center of mass passes, that is considered as the reference line. So above this line, this is L by 2, this is L by 2. So potential energy of this mass at this point will be mg L with respect to this reference line. Now, there is some potential energy of this mass. So to find that, I have to find this height. Now check. This length is L. This length is L. So we can consider by dropping a perpendicular, if this entire length L, then by 2, then this will be L by 2 cos theta. By dropping a perpendicular here. From this point I drop a perpendicular on this line. Then this one is L by 2. So this length up to the foot of the perpendicular is L by 2 cos theta. Now we know that from this point to this point, that length is also L by 2. So what will be the remaining length? That can be written as h. So that h will be mg L by 2 into 1 minus cos theta. mg L by 2 into 1 minus cos theta. Now since I find h, then above this line, what is the potential energy at this point? mgh. That is simply mg into L by 2, 1 minus cos theta. Clear? So we consider when this pendulum bob, suppose the pendulum bob goes here. So what is the increase in change in potential energy? From that we can find this height. Same thing. I consider this length here is moving at this point. So this is L by 2. So we drop a perpendicular here, that is L by 2 cos theta. So the remaining entire length is L by 2. So this remaining length is L by 2 minus L by 2 cos theta. L by 2 common, 1 minus cos theta. Okay. Now, let us consider at this point it has an angular speed omega. Then it has some kinetic energy. Kinetic energy is half I omega square. Half I omega square plus potential energy at this point. That is, so H, I write the mgh actually. mgh, the entire potential energy at this point. That is mgh, that is equal to mgl initially. Okay. So I calculate the potential energy at this point. Potential energy at this point. Then there is kinetic energy, but there is no kinetic energy. So total energy conservation, mechanical energy conservation, I applied. So now we can write this one as half. Now I is calculated with respect to this point because this is the axis of rotation. So about this point, moment of inertia is 1 by 3 ml square. So it will be 1 by 3 ml square into omega square equal to, on that side, mgl minus mgh. mgh means mgl by 2 plus mgl by 2 cos theta. Okay. I substituted both the values and subtract. Minus mgl by 2 cos theta. Then it can be written as 1 by 6 m l square omega square equal to, this subtraction will give you mgl by 2. There is also mgl by 2, so I take mgl by 2 common into 1 plus cos theta. Then m cancels, 1 l will cancel, so it will be 1 by 6 omega square equal to g by 2, 1 plus cos theta, that is 2 cos square theta by 2, 2 cos square theta by 2. So this two cancels. 1 L is there. L is there. Okay. This one. L omega square by 6. Because 1 L is cancelled from both sides. Then omega equal to 6G by L under root cos theta by 2. That is option C. Okay. So you have to use conservation of energy at the 2 points, mechanical energy at the 2 points. Initial point is vertical, then at an angle theta with the vertical in the bottom side. Then 77. A boy and a man carrying a uniform rod of length L simultaneously in horizontally in such a way that the boy gets 1/4 load if the boy is at one end of the rod, the distance of the man from the other end is. Suppose this is the rod. So its weight will pass through its center of mass, that is W. The ball is at one end. Let us consider here. So boy is balancing a weight of W by 4 because only 1/4 weight load is such a way that boy gets 1/4 load, means the normal reaction at this end by the boy will be 1/4 of the total load. Total load is W. So the normal reaction given by the boy will be W by 4. So he will feel W by 4 weight. Then remaining 3W by 4 is acting on the other person. Then suppose that person is here. Boy is here, that person is here. So over his head the load will be 3W by 4. Remaining part. Now see, we have already used the translational equilibrium condition. That means net upward force equal to net downward force. So now we have to write the equation for rotational equilibrium because the rod remains horizontal. Okay. Let us consider this man is at a distance x from the other end. That we have to find out. Then boy is at one side and this is the midpoint, so this is L by 2. The entire length is given L. Now we want to calculate the moment of this force about any of the points. About any of the point, by taking moment I can solve the problem. I will take the moment about this point. Okay. You can also choose this one or this one or this one. Anything. Any choice is, well, you can solve the problem. I will choose this point. I will choose this point particularly. Okay. Now, there is no special issue in taking that point. Now, if I consider this moment about this point, that is torque. So this one will produce a torque in this side. That is it. This torque will try to rotate it clockwise. This torque will try to rotate it in this side. About this point, two forces, two torques will be this one in this way, this one in this way. So both the torques are opposite in direction. Now, if they are also equal, already they are opposite. Now, if they are equal, then net torque will be 0 and the beam will remain horizontal. That is the condition. So torque of weight about this point will be W into perpendicular distance, that is L by 2, because this is L by 2, so the remaining distance is L by 2. This is equal to weight carried by the other person, load carried by the other person, 3W by 4 into the distance from this point is L minus X. And the torque due to W by 4 is cancelled because we choose this about this point, so line of action of W by 4 passes through this point and produces no torque. Similarly, if you choose the center of mass, then W will produce no torque. If you choose this point, then this particular force 3W by 4 will not produce any torque. You can choose any other point and solve also. Now find X from this. So it will be 2L equal to 3L minus 3X. So 3X equal to L, X equal to L by 3. So this man is at a distance L by 3 from the other end.
So it should be 2L by 3.
Which one? I multiplied these two on that side. So it will be 2L. It will be 3L minus 3W. 3L minus 3X. So this 3X is taken on that side. So this will be 3L minus 2L, that is L. So X will be L by 3. So I multiplied these two here. Now, for the next question, we require a formula that is tau equal to pi r to the power 4 theta by 2L into theta. Where tau is the torque when suppose there is a rod fixed at one end and you are trying to roll this. So that is called a torsion. Due to torsion, there is a change in the dimension and configuration. That's why this comes under elasticity. Now, here this eta is not the normal rigidity modulus that we consider. Here this eta is called torsional rigidity. Previously we know that shearing stress, shearing strain. So now it is torsional strain. So for that this eta is called the torsional rigidity. And this theta is the angle of twist through which the it twisted. So that angle of twist. So in this particular case we can write that r to the power 4 into theta equal to constant for this particular problem, because length same, torque same, eta same, then r to the power 4 and theta, this product is constant, means theta proportional to 1 by r4. Now you can find the answer. So answer will be r2 to the power 4 by r1 to the power 4, because you require theta 1 by theta 2 twisted in the angle of twist in rod A by angle of twist in rod B. Since it is inversely proportional, it will be r2 to the power 4 by r1 to the power 4. Okay. So it will be option C. Next. three successive resonant frequencies of an open in an organ pipe are 1310, 1834 and 2358 Hz. The frequency of the first overtone is. So from this first you can calculate the ratio. Suppose it is given, say N1, say N1 by I will consider Ni, ith harmonic. Okay. So Ni plus 1 by Ni. That is coming 1834 by 1310. Three successive. So I consider the minimum to be Ni, ith harmonic. Then I consider I plus 1th. Then I will consider I plus 2th. Okay. So Ni plus 1 by Ni. That comes 1384 by this one. Then calculate also this one. Ni plus 2 by Ni plus 1. That is 2358 by 1834. First one is coming. Check what is coming. So if you divide this one by 2, it will be 917. Dividing this one by 2 will give you 655. 655. Then okay, then which odd factor it will divide? Seven. 7 it will be 7. No, not 7. Not 7, it's some other. Check. We have to find out the smallest number by dividing this. That is 1834 divided by 1310. 4, 2, this one is 5. Okay, put a point, it will be 0. So it will be 1.4. So 1834 by 1310, this is coming 1.4. 1.4 means I can write 14 by 10, that is 7 by 5. Okay, 7 by 5. Next one, do the same thing and calculate. Just divide. It is better to divide. Area of this division.
Nine by 7, sir.
9
by 7.
9 by
Seven.
7. Any other confirms? 9 by 7. Or calculate. 1834 is 2358. 1834 4 2 5 point 0 will come. This term is coming 4. This term is coming 2. This one is coming 5. 5240. Then if I multiply with 4. 4 is not possible. 3, 5. 5 4s are 20, 0, 2. 5 3s are 15. 7. How much it is coming? 1.28. First one is it will not come. 4358 divided by this one will not come. 1.8. Just a minute. Rather to divide this one, it is better. Divide with this, just divide with this fundamental. First one, that is 1310. Divide with this 1310, that is 2358. 1310. 1310. 8 4. This one is 10. 0.0. 8 0 8 104. Divide first, the third one divided by first one, then it will become 1.8. 1.8 means 18 by 10, that is 9 by 5. Okay, so Ni is 2, Ni plus 1 is 2, Ni plus 2, that is equal to 5 is to 7 is to 9 in this ratio. 5 is to 7 is to 9. ডিভাইড করলে 9/7 আসতো, এই ধরনের মড আসছে। রিক্সাটা মেলাতে প্রবলেম 7 দিয়ে ডিভিজিবল বলে মেল না 5 দিয়ে ডিভিজিবল হলে 10 এর মাল্টিপল চট করে চলে আসবে if I divide the previous case then it will come 9 by 7 if 9 by 7 is not matching exactly so that due to divided by 7 the point will come and it will not matching properly with the fraction but since here it is divided by 5 then it will come immediately in the fraction okay so 5:7:9 means only odd harmonics present so we can consider this is a closed organ pipe now we require the successive resonance frequencies of an organ the first overtone that you have to calculate so for this first find the fundamental frequency this one is 5n0 is then 1310 5n0 will be 1310 okay because this is 5n0 this is 7n0 this is 9n0 so 5n0 is 1310 then from this calculate n0 262 okay so it is 262 hertz then you have to calculate first overtone which overtone is the first which harmonic is the first overtone in or closed pipe third harmonic so you have to find the value of the third harmonic that is 3n0 n0 is this one so it will be 786 hertz okay next two rods of copper and steel having same area of cross section but different length L1 L2 respectively are connected to each other the combined length of two rods fits between two walls without any stress on walls okay if alpha 1 alpha 2 are their coefficient of linear expansion y1 y2 with increasing temperature y2 are their Young's modulus with increasing temperature see if it will not exert any stress on the wall then the total length will remain same total length will remain same means if one increases then the other should decrease so combined length remain same and now if one of the rod due to expansion increases then other should decrease must have negative expansion coefficient other rod must have okay so if for one alpha is positive then for other alpha will be negative then only it will not exert any stress on the wall because if total length increases then it will definitely exert stress so option B is correct next one a charged particle Q is placed at the center O of a length L. Another of a length L. Another same charge Q is placed at a distance L from O, the electric flux through BC is through the ABCD, electric flux through the ABCD placed at a distance. Q is placed at the center O of the cube of length L. Another same charge Q is placed at a distance L from O. Okay. And root 3 L by 2 from B. Then the electric flux through ABCD. It is placed symmetrically. Since it is placed symmetrically, then both charges will produce same amount of flux in equal and opposite. না এই রুট 3 L by 2 টা আবার করতে দিয়েছে এটা না দিলেও তো রুটটি কি করতে রুট 3 কি ক্যালকুলেট করে একবার দেখে নিই লেন্থটা রুট 3 L by 2 করছি না তাহলে
এইখানে একটু ডায়াগোনাল ডিসটেন্স
হ্যাঁ
এটা
হ্যাঁ
ডায়াগোনালে হাফ
root 3 into length L by 2 হ্যাঁ মিলে যাচ্ছে তাহলে সিমেট্রিক্যালি প্লেস তাহলে ঠিক দেওয়ার কোনো দরকার ছিল না বেকার see the situation is that this is the cube this is the position of the one charge, this is the position of the other charge. Okay, now we can consider from this surface is at equal distance and this surface is at equal distance from this charge, means with respect to this particular surface these two charges are placed symmetrically on the two opposite sides. This is just like a sheet. One charge is placed here, another charge is symmetrically placed here. So net flux for this charge and net flux through this charge through this surface will cancel each other. So net flux passing through this surface will become 0. Next one, the capacitance of parallel plate capacitor is CA. Just you calculate CA, CB and CC and then compare. First one, when there is first case CA. So CA will be epsilon naught A by B. Simple. In the next case, a dielectric slab is present. Now we can consider that it is the series combination of two capacitors. When the dielectric is inserted, I can consider it is the series combination of the two capacitors. In case B, so we can write that 1 by CB, that is the equivalent, that is equal to 1 by C1. C1 is an air capacitor in the B combination. So air capacitor of epsilon naught A by D by 2, because the length is half. Another is K epsilon naught A by D by 2. So these two are in series. Because it is half filled with a dielectric, so we can consider a vacuum portion is a capacitor, dielectric portion is another capacitor, and their series combination is there, is option in case B. So 1 by Cb will be equal to 1 by C1 plus 1 by C2. From that you can calculate Cb. So 1 by Cb equal to d by 2, so it will be 1 by this 2 by 2, this will be 2 epsilon naught A by D, 2 epsilon naught A by D, so that D will come here, so it will be D by 2 K epsilon naught A. Okay. 1 by Cb equal to then D by 2 epsilon naught A 1 plus 1 by K, 1 plus 1 by K, that is K plus 1 by K. Now epsilon naught A by, we can write this one as Cb equal to 2 epsilon naught A by D means Ca into K by K plus 1. Okay. So Cb equal to 2Ca into K by K plus 1, because epsilon naught A by D means Ca. So we substitute that. Then the third one is series combination. So we can consider Cc, that is coming C1. So first one is epsilon naught A by 2 D. Second one is K epsilon naught A by 2 into D. So now we can take epsilon naught A by 2D common. It will be 1 plus K. Now the epsilon naught A by D means Ca, so Ca by 2 into K plus 1. Now from this you have to compare and find the correct option. So both Cb and Cc are greater than Ca. Okay. Cb is greater than Ca and Cc is also greater than Ca. Because don't confuse with this term, there is 2. So it will be 2k by k plus 1 and k is greater than 1. Since k is greater than 1, so 2k is always greater than k plus 1. So option A is correct. Because if you calculate Cb by Ca, then it will be 2k by k plus 1. Value of k, dielectric constant, that is always greater than 1. So we can write that 2k is greater than k plus 1. So Cb greater than Ca. Similarly in this case Cb is greater than Ca. CC is greater than CA. So both CC and CB are greater than CA. Next, you have to apply Kirchhoff current law by considering a potential at the junction point. Three resistors connected from the T shape are shown. Suppose the junction point has a voltage of X. Suppose junction point has a voltage of X, then we can consider that if a current goes like this, I, then it is divided into two parts, I1, I2. Then according to Kirchhoff current law, I should be equal to I1 plus I2. I consider voltage at this junction as X, and it is given +2 -4. This one is given -8. This one is 4 ohm, 8 ohm, and this one is 2 ohm. Okay. Then high potential minus low potential, that is 2 minus X by 2, that is I. 2 minus X by resistance, that is I. Similarly, I1 will be X minus 8, that means X plus 8 by 4 plus I2 X minus of minus 4, that is X plus 4 divided by 8. So solving this, first find X. Then once you find X, then you can find the value of current. Cancel 2 from all the terms, 4, then it will be 2 minus X equal to, this is 4, 2X plus 16 plus X plus 4. So it will be 8 minus 4X equal to 3X plus 20. So it will be minus 7X equal to 12. So X equal to 12 by minus 12 by 7. X equal to minus 12 by 7 volt. Okay. Then this point X minus 12 by 7 volt. This point minus 8 volt. So this is comparatively high potential and this is the low potential. Then current will flow in this direction and that is I1. Then that I1 equal to, this is 4 ohm, so 4 I1, that is equal to minus 12 by 7 minus 8, means minus of minus 8, that is plus 8, minus of minus 8. Calculate. So I1 will be minus 3 by 7 plus 2. Seventeen by 7. Eleven by 7. 14 minus 3. 11 by 7. So it will be nearly 1.57. কিলো ওহম ঠম হয়তো হতো যেটা মিস হয়েছে বা অপশনে ভুল প্রিন্ট হয়েছে তাহলে আমি কে এসেছে See, the options are given in terms of milliampere, but that is not correct. Either it should be in ampere, otherwise the resistance should be in kilovolt. Then current will be in milliampere. Okay, 84. A parallel beam of light is incident normally on a plane surface, absorbing 40% of the light and reflecting the rest. If the incident beam carries 60 watt of power, the force exerted on the surface is. First calculate the initial momentum, then final momentum, then their difference in 1 second. Here change in momentum per second is given. I per second, change in momentum per second, that is pi by t, suppose that is 1 second, that is equal to how much energy flux is falling? 60 watt, that is in joule per second. So that's why I write p by t. So momentum p equal to e by c. So this is E by C, that is 3 into 10 to the power 8. Calculate. This will be 20 into 10 to the power minus 8. Okay. That is the incident momentum per second. Then, how much is absorbed? 40% is absorbed. So the remaining is reflected. So the reflected percentage calculate. So on this 60 watt, 60% is reflected. Okay. So 60% of this one is 36 watt. So 36 watt is the reflected momentum per second. So Pf by T in 1 second will be 36 by 3 into 10 to the power 8. That will be 12 into 10 to the power minus 8. Okay. So what happens? The light falls with 60 watt energy, 60 watt power. So change in momentum per second, incident momentum per second first we calculate. That is Pi by T, that is 20 into 10 to the power minus 8. Then 40% absorbed, means remaining 60% is reflected. So for reflected momentum per second, that we also calculate. Don't subtract, add the two values, because this is incident momentum, reflecting momentum changes the direction. So vector subtraction here means with the direction. So you have to actually add two momentums. That means mv minus of minus mu changes the direction. So it will be mv plus mu. So there it is a vector subtraction. That means in the scalar form it will not be the subtraction always. It depends on the direction. So it will be, since it is reflecting, so you have to add the two values to find the change in momentum. Like that mv it is striking, mv it is coming back. So total change in momentum is 2 mv, not 0. So it is like that. So 20 plus 12, that is 32 into 10 to the power minus 8 Newton. That means 3.2 into 10 to the power minus 7 Newton. Correct option is B. The velocity of the electromagnetic waves in a medium of dielectric constant 4 is velocity of light is also given in air 3 into 10 to the power 8. The value of mu is 2. No, velocity of the light value of mu is 2. Value of mu for this particular calculation is 2. That is root over of the dielectric constant. So C by mu will be V. That is 1.5 into 10 to the power 8 meter per second. This is coming from the formula C equal to 1 by root over of mu naught epsilon naught. Then for the other medium V, then permeability is same for both, and only there is a change in the dielectric constant. So dielectric constant is given 4, so mu will come out 2. Okay, so V equal to C by mu, so C is given, so C by 2, that is 1.5 into 10 to the power 8 meter per second. you can directly use this formula also. C equal to 1 by root over of mu naught epsilon naught, and in the other V equal to 1 by root over of mu epsilon. From that you can find the ratio. If mu is same for both, then it will cancel, and from that you can find the ratio of epsilon by epsilon naught, which can be substituted as K and solve the problem. Without introducing the concept of mu directly, you can apply. Next, the diagram shows energy levels for an electron in a certain atom. Which transition shown represents the emission of photons with most energy? Most energy means low wavelength. Most energy means low wavelength. Directly you can calculate with this formula. Okay. Which combination will produce least wavelength? For that, energy emission will be maximum. So it will come when the transition is from 2 to 1. 2 to 1 means least wavelength. Least wavelength is maximum transition. Longest wavelength is from infinity to initial, and least from next one to the initial. So here it is, when transition from 2 to 1 will occur, then it will have least wavelength, so corresponds to maximum energy. That is, option B is correct. Next, 87. Just find the peak value. 200 volt is the RMS value here, so 200 into root 2. It will be the peak value. Okay. Then, in Fraunhofer single slit diffraction experiment, width of the central bright band is twice the width of the third bright band. Just put in the formula, single bright band has a width of 2 lambda d by small a, 2 lambda d by small a, that is linear width. Linear width is 2 lambda d by small a, and third order means 3 n minus half lambda d by 8. So from this you can find that if you put n equal to 3, third order, then its width will be 3 minus half. That will be 5. Third order, n should be 5 by 2. Just a minute. Linear width of the central bright, that is 2 into lambda d by a, 2 into lambda d by a, third bright band. What is the width of the bright? Third bright means here is 2. Third bright band formula রয়েছে এটা 0 তে হবে 5/2 আসছে it is coming 5/2 তো অপশন কারেক্ট অপশন কি করে হচ্ছে তাহলে হচ্ছে না central bright band width that is 2 lambda d by a and for other it will be this one n minus half okay n minus half or n plus half we can also consider this one then it will be the linear width. Then if you put n equal to 0, that will match. No one will match because that odd factor, even factor will not come. Here it is given first one, second bright. No one is matching. Okay. Next one, 89. A massless rod of length L is suspended by two identical strings AB and CD of equal length. A block of mass M is suspended from O such that BO is equal to X. Further, it is observed that the frequency of first harmonic of AB is equal to the second harmonic frequency or in CD, then X will be. Okay. See, you can consider that 1/12 root T by M, that is the frequency of the fundamental of a straight string, fundamental frequency is straight string. So 1/12 root T1 by M in the first string will be equal to 1/L root over of T2 by M in the second string. Okay. Where M is the mass per unit length which is given same. Second harmonic in the second string, so it will multiply by 2, so it will be 1/L root over of T by M. So from that first calculate the ratio of T1 and T2, of T2 in terms of T1. So M will cancel, so 1/4 T1 by M equal to T2 by M. So T2 equal to T1 by 4. Now this is the string, this is the rod. On this side there is T1, on this side there is now T2. This one is considered to be massless. This block is hanging of mass M. Okay, about this point O. entire rod to remain horizontal, the moment of force about any point should be 0. So if this is x, this one is L minus x. So about point O I calculate the moment. So this produces a moment T1x, this produces a moment T2 into L minus x. So net moment will be 0. Then just substitute T2 equal to T1 by 4. So T1x equal to T1 by 4 into L minus x. So 4x equal to L minus x. So x equal to L by 5. Next one, a light ray is incident perpendicularly in one face of a 90-degree prism and is totally internally reflected at glass air interface if the angle of reflection is 45 degree. We conclude that the refractive index on the surface from where it is reflected, that angle of incidence is 45 degree. That I on that surface from which it is totally internally reflected is greater than theta c. This is the condition for total internal reflection. Then I is given 45 greater than theta c. So take sine on both sides. So sine 45 greater than sin theta c. Sin 45 means 1 by root 2 and sin theta c means 1 by mu. So mu greater than root 2. This will mu greater than root 2. There was one question in mock paper 52. Question number 81. Apparent volume expansion, that means Vp apparent, that is equal to V naught into 1 plus gamma apparent into P. Gamma apparent into that is capital T. Okay. So this one can be given increase in apparent volume. So this is Vt finally. So we can write this one as V minus V naught, that is equal to V naught gamma apparent into T, apparent expansion coefficient into T. Then this one can be written as V naught into T. Gamma apparent means gamma real minus gamma solid. Gamma real for means gamma for mercury, M minus gamma for the solid container. Gamma for the solid container or glass container. So we write gamma G. Because we know that gamma real equal to gamma apparent plus gamma of the solid container. Gamma real equal to gamma apparent plus gamma of the solid container. So this one is now can be written as area AT into new length, that is H, area AT into H this is the increasing volume apparently, so it will be area in new area into H, so that will be A naught into 1 plus beta T into H, that is equal to V naught T into gamma M minus gamma G. So it is A naught into 1 plus. Now beta is 2 times alpha G, 2 times alpha glass into T into H equal to V naught T into gamma M minus 3 times alpha G. Because only alpha and gamma for mercury is given and alpha for glass is given, so beta for glass and gamma for glass will be 2 times and 3 times, because alpha is to beta is to gamma, for solid is 1 is to 2 is to 3. Then from this we have to calculate H equal to V naught T into gamma M minus 3 alpha G by A naught into 1 plus 2 alpha G into T. So that is option B.
Sir, there in the formula you wrote plus, sir, and there you wrote minus.
Which one?
That one, sir. Top right, sir.
Here,
Yes, sir.
gamma real, gamma apparent value is gamma real. Gamma real means for mercury
Yes, sir.
minus gamma solid for glass. That one is written.
Above you wrote plus, sir.
This one?
Yes, sir.
I want the value of this gamma A too. Gamma A will be, this one will be on this side, so it will be minus na.
Yes.
Hey, don't confuse.
So,
This is gamma real. Here we have to put gamma apparent. So gamma apparent will be gamma real minus gamma S. Okay. So it will be gamma M real means for mercury M and S for glass.